record by this. So this recorded file will be uploaded to YouTube later. Okay. So then I will add it to a list. See, I think okay, maybe I have to share my screen, right? I share my screen like this so you can see. Hope you see. So then I have, as I think as everybody should know, I have here, if I go to my playlist, I don't know, you cannot see this playlist from my account, but I already gave you playlist. I think in your system, educational system of Ho Chi Minh University of Technology, you have this how do you call this? Some system, right? Where I already gave you this playlist link. Then let me see. Okay, so then now I put, because we have some skipping of chapter 3 and chapter 4, and I actually don't like skipping things in textbook. My policy and my value is we do one by one, very straightly follow the textbook from beginning without skipping and without with full understanding, okay, without skipping any part which we don't understand. We try to understand everything one by one very carefully from very beginning, following the one specific textbook. That's my policy and my belief and like value. So I tried up to number 11, no, number 18, doing chapter 2, but I had to skip chapter 3 and 4 because the class is so much behind, and the course designed by Professor Na, he suggested we can skip chapter 3 and 4, right? So I started chapter 5, so which is this video number 101, 102, and 103. And as you know, I'm pretty behind in a sense, okay? Because I don't understand the detail of this textbook. Okay, so maybe I just stop. Then today I think I want to, I have to share this screen, right? Let me see, I have to share a screen, which is not so convenient. Anyway, so today I want to discuss about this textbook, okay? Some part uh, before. Okay. We started this deformation chapter. Then there's a two things, large x and small x. And this first paragraph, actually I don't see much explanation. Maybe this is the thing. Undeformed and deformed configurations. Do you agree? I don't know. Undeformed undeformed configuration has position X. Deformed configuration, I'm sorry, has the position small x. Then later they say this is material coordinate. They call this spatial coordinate. Spa spatial, spatial, spatial coordinate. And unfortunately, I don't understand this difference much. See, we use alpha e. This is same thing, you know. Alpha goes like 1, 2, 3. I also go to 1, 2, 3. So this is more like x1. X1 is x1 e1. Small x1 is small x1 e1. Then this e and this e are same thing, you know. So we are using the same Cartesian coordinate, right? Then I'm pretty confused. I'm still confused. What is the difference between large x and small x? Isn't that very strange or difficult? And one of them is called undeformed configurations and also called material coordinate. And the other one is called deformed configurations. Yeah, deformed configurations and has spatial coordinates. Okay, then I can tell you another thing which so this one. So partial alpha is actually partial large x, yeah? And partial I is small x. That's the difference. That's why we use alpha and I. Although both alpha and I means 1, 1, 2, 3. And this is clear, I think. You can describe x, small x, in terms of large x. It's okay. Just some mathematical function. And you can also describe large x in terms of small x. This is also a mathematical function, so not so much big problem. Then here you have this. I don't know if you see this. Anyway, okay. Then there is a deformation of body, figure 5.1. And this is kind of mysterious. So they said this is undeformed. And this is deformed. And this is called material coordinate. Material coordinate. And this is called spatial coordinate. Then you can see the vector x, vector large x, and vector small x, and both has the same origin. Yeah? Then there is a vector from large x to small x. So I can say, okay, maybe use a red one. So this one, vector from large x to small x is called large U. Then there is another vector, which is small u, which is a vector from large x to small x. It's same. So I would say large U vector is small u vector. I just don't understand complete meaning of material coordinate and spatial coordinate. See, here you see spatial coordinate or Eulerian coordinate. This is small x. Yeah. So then large x is the material coordinate or Lagrangian coordinate. So I want to ask you if anybody understand the meaning of these two things. Yeah. And if anybody can explain or give me a hint about these two things, please let me know. See? Oh, somebody gave me something. How can I go this? How can I go to the next this one? Hmm? How can I open this? Answer? Is it number one answer? Would you mind to share with us your course curriculum? We can prepare questions ahead of entering class. What is this? Part 2, Part Formula 236. Okay. We have some course plan, right? And we are actually going very straight. At least my part, I'm doing very straight. So if you go to like YouTube, you can see here. See now today, I don't know if I posted today's. I think I posted today's part. So I already posted today's part to the to the playlist. So where I give you information. See, we are doing from page 52 to chapter 5. Okay, this is already given, right? So that means we are around this part. Okay, so we try to do next like 53 page, chapter 5 or something like that. So this will tell you where to prepare and where to ask questions beforehand, right? Another thing, we actually have more complete or big plan, the whole plan of this class. I have from Professor Na, I have some, I think we have some, it's a little bit before this one. Yeah, this one, right? So can I copy? Or am I not sharing? This is very difficult to use. Okay. See, I can share, right? So is it shared? Is it shared? So then, like here, and I don't know if I can make this big. So there is some. Yes, I hope doesn't seem working. Shall I give my next lecture February? Okay. This is Google Meet. This one is. This is the plan. How do you call this? Do you say plan or schedule or? Let me see. How can I open this? How can I open this? I can. Okay. I think I save this first. Okay. Then okay. Then I go to. Hey, my computer is so slow. Doesn't responding. I don't know what to do. Very bad. Here, this may work. Okay, this worked. So this is the plan. Unfortunately, January 10, January 31, these class were cancelled by some, I don't know, from administrative department notified to us that these two class before the lunar vacation are cancelled or no class. So then, like I have, usually Japanese celebrate solar new calendar, not like lunar calendar. So we celebrate New Year January 1st. January 1st, like Christmas, after Christmas to the first week of January, our vacation. Yeah, then as soon as our vacation end, your vacation started, and your vacation is not so long, but the class both before and after your vacation were cancelled or skipped or something. So I started my, I'm sorry, my software is so bad. See? So I started my class in February 7, right? Yeah, chapter 2. Then I was supposed to start teaching chapter 5, February 14. Then February 21, chapter 5 again. So today I am supposed to teach chapter 6, but I'm far behind, right? So I don't know. Because I think to understand basic concept is very, very important. But this textbook doesn't explain the basic concept much. And that just show a mathematical, you know, how do you say, equation, uh, we call 数式変形. Let me see, let me go to Japanese dictionary. Deformation. See, my PC not working very well. Where is the, oh, okay. Very, very slow to pop up. Oh, okay, okay. And this doesn't work. I think because we are sharing this uh, full screen, you know, some function of Microsoft Windows isn't working. See, we call 数式変形. And in the beginning, you know, I was asked to teach everything in Japanese, but then in the end, in the like very last minute, before starting class, Professor Na decided we do everything in English. So because otherwise Professor Na doesn't follow what I say, right? Anyway, even if I speak English and give lecture in English, I'm not so sure about whether Professor Na is following or listening my lecture or video, because I'm like telling a lot of messages to him during my class and video lectures, but it doesn't seem he's noticing that. Anyway, so we call this, let's see, this is ego formula transformation. Formula transformation. Yeah. So I think this textbook focused a lot about this formula transformation, or just like showing, just listing formula from one formula to another, formula, and without explaining the concept much. I think that's a big problem of this textbook, and because once you understand the concept, you know, it's not so difficult to, you know, follow, understand uh, the formula. Okay, formula, you can just make formula by yourself from concept if you understand the concept. Let me stop. Let me stop the share screen, okay? And I hope it go back. And then I think you need this schedule, right? Tentative schedule. I would say a tentative schedule. And I don't know if anybody else. Would you mind to share with us your course curriculum? You can prepare questions. You can yeah. So then I give you this course, tentative course curriculum. Is it? I cannot place it. So how can I do this? I cannot put it here. Yeah. So I cannot put it here. So how can I give you this? What is a good idea to give you some file to you? can do you use like do you use a Twitter? Maybe Twitter. Okay, maybe let me try Twitter. Okay, here you can see that our tentative plan of whole course. But as you can see, we are pretty much behind. Okay, so are there anybody who want to say something? Okay, we have some time. It's still what time? 2 hour difference. Right? It's 8:30. Right? We still have different time. So then, are there any numbering to you, or how can I? Let me see. I can change layout this way. Okay, so we can spot. We can like. Oh, somebody is talking. Hey, this very difficult to. How can I? No, I have to type each time. I have to type. Oh my God, this is not so good. Why they don't allow me to highlight name? Very strange. Let me see. I need some paper note to here. So it takes some time, to copy your name to Rung. Yeah, please say something. Here, wo Trung. Uh, just you can in Japanese or English, whatever. You can also share. Sorry. Please ask. I would ask Hieo Wo Chung say something to us. You can use my mic broken. Okay. So then, but you because you don't your mic is on anyway. So then I go from top. Each name I had to write on my paper. Nuguyan, Tran, and some of your name is very long. Tran Tian. Yeah, An Nguyen Tran Tian. Can you say something?
Hey, I'm here.
Oh, okay. You can also use your screen and share your screen and say something. One topic is this: what is the difference between material coordinate and spatial coordinate? And what is the difference between big X and small x? If you have no idea about it, you can say something else as well. But please say maybe 1 minute. Hmm?
Uh, the difference between material and spatial coordinate, is that right?
Okay, so uh, okay, I go to next person. Dan Nguyen Hai. Is it okay? Dan Nguyen Hai. Okay, if you have no idea about this material and spatial coordinate, you can say anything else. You can just speak whatever you think, and you can speak in Japanese as well, in English or Japanese. Maybe 1 or 2 minutes. Okay, so please. Okay, yeah, this one I still don't understand. It's okay, original geometry, while the spatial coordinate are solution depend. Solution, what is the original and the solutions? Original is some material without any force or without deformation or without force. And solution you mean is the material which is already deformed by some force. Is that what you say?
Yes, that's
Uh,
what I said. That's
okay.
how I
Okay.
yes.
I try to study by myself. So thank you. なんだっけ? Dan Nguyen. Did we finish Dan Nguyen High? Please, Dan Nguyen High. Please say something. 1 minute. Okay, okay. So uh, we go next. Whatever. Do, tran, an. Can you say something? Hmm? Okay, so duem, V, tan. Duen Bui Tang? Can you say something, please? You can like type in chat. はい、お願いします。You can speak in Japanese. 日本語でもいいですよ。何か日本語で喋ります？時間がなくなるから、とりあえず先に進みます。後でまた時間余った時に喋りたい人に喋ってもらうっていうふうにしたいと思います。よろしいでしょうか。さあ、次は、ホアン・ユ・ヌグエンさん。Can you say something? Or, こんにちは。
こんにちは。
どうでしょうか。バンド
あ、はい、はい。
もうちょっと大きい声で言ってください。
はい、はい、聞こえます。聞こえます。
聞こえますよ。
はい、聞こえます。
なんか大きい声で言って。Can you speak a little louder? あ
あ、OK, OK.
See, I still don't understand this material coordinate and spatial coordinate. Even if you deform material, the coordinate, they use the same coordinate, right? It's very, I have to say, very strange. Deformed coordinate and, uh, maybe okay, maybe okay, okay, maybe okay. はい、次は誰でしょう？なんだっけ。ふん、ふわだい。Did I skip anybody? Am I skipping Huan Yu Nguyen? I searched on the internet material coordinate system. Okay, I will read it later. Okay, let me see. Let me read it. Oh my God. Okay. I searched on the internet material coordinate system that describes the position of particle within a material as it deforms. This system follows the motion of each particle and is known as Lagrangian coordinate system. Material coordinates are useful for understanding how the individual particles within a material are moving and deforming, which is important for analyzing the behavior of materials under different conditions. Spatial coordinates are a system that describes the position of objects in space. This system remains fixed and is known as Eulerian coordinate system. Spatial coordinates are used to describe the position of an object relative to a fixed point in space, such as the origin of Cartesian coordinate system. This system is useful for understanding the motion and deformation of objects as they move and change shape in. See, to me, I don't understand material coordinate. Material coordinate in this textbook just looks as if it is spatial coordinate. Do you do you do you maybe see I share my screen, see this one, see this is spatial coordinate, right? Why do they say this is material coordinate? This is, to me, this looks just like spatial coordinate because you have some origin and there is some point of the material. Why do they say this material coordinate? And if something is deformed, you call this spatial coordinate. To me, it's more reasonable if we have material coordinate here and spatial coordinate here. Yeah, if we have in if we have both coordinate in for this, and if we have both coordinate for this math code spatial coordinate, then it's more understandable. If you have one case like B0 case, undeformed case, if you have two coordinates, so if we describe this undeformed material in material coordinate and spatial coordinate, then if we can describe this thing, deformed thing in terms of material coordinate and spatial coordinate, then maybe I can understand the situation a little bit better, But according to this textbook, this original undeformed case, the coordinate is called material coordinate and Eulerian coordinate, yeah, a Lagrangian coordinate or whatever. Then for deformed case, we use spatial coordinate and Eulerian coordinate, which I don't understand. Then you mix large X material coordinate and small x, which is spatial coordinate. You mix it. You mix this big X and small x. In a sense, the difference can be called large U or small u, and it's same. In the end, this is the same. Large U and small u is the same, equal. So I'm completely confused. So do anybody have suggestion? Anything? Okay. Material coordinate describes the position of an object relative to itself. Spatial coordinate describe position of an object relative to fixed point. Yeah, it is okay, but what is itself? Describe the position of object relative to itself, right? What is itself? So this is the position of an object relative to itself, right? Then that means zero. I would say, see, if you describe the position relative to itself, then it is zero. Isn't this zero? The position of object relative to itself. So if you take the origin as the material position itself, then the material position is just a vector zero. position of 私はヌグエンバンヌグエンです。じゃありません。I'm sorry. I'm sorry about that. 間違えました私は間違えましたか何かで。マテリアル、I think I read these all. There's something that makes me confused. Could you explain to me why the axiom of continuity requires that these matrices be non-singular? You can explain me in next week because I think we don't have much time left. Thank you very much and fully enjoy your day with family. Yes, you know, first of all, as I said in my video, I don't much worry about singular or non-singular. Okay, non-singular, and they gave us this condition. What time is it now? You want to stop at 8:50, right? You want to stop it 8:50, very strictly. Okay. I don't know. Do you have another class from 9 o'clock? Is that the case? You want to stop so strictly? Is that because you have a class at 9 o'clock? I'm very confused. You are very strict about ending time, although the starting time is very relaxed. Many people are very late, and we start the class very late. On the other hand, like many people are very strict about ending time, and I'm very confused about it. So I would appreciate it if if anybody can explain your situation so that I can understand you guys better and can do a better class. We have a Japanese class at 9 o'clock. Okay, so we finish today and I will try to do something good next week. I'm sorry, I don't understand Vietnamese. Okay, so see you. Bye.